Good morning, good afternoon, and good evening, everyone. I'd like to welcome you to the IEEE side event for their 9th Multi-Stakeholder Forum on Science, Technology, and Innovation for the Sustainable Development Goals. I'm Karen Mulberry, and I would like to introduce you to our session. The focus of this session is on energy. And as Ban Ki-moon noted, it is a golden thread that connects everything around the world. It makes development possible, and it is the underpinning support for the progress in our sustainability goals. Now, for our session, here is the agenda. We're going to be focusing on progress and what are the sustainable and renewable energy solutions, with several experts providing their opinions and insights on how progress is being made and what are the challenges and the opportunities going forward. At this point, I'd like to turn this session over to our moderator, Rudi Schubert, who is Director, New Initiatives for IEEE, the Standards Association, and also the lead for our energy practice. Rudi, over to you.
All right, thank you, Karen. And I hope the audio and video are coming through fine. To get us started, I have this slide up here talking about how IEEE addresses the Sustainable Development Goals through collaborative and multi-stakeholder standards development. I think if we take it a step back, we have tremendous challenges ahead for us with everything to do with sustainability, energy transformation as we move forward. And as I've said to some of my colleagues, really the key is collaboration and cooperation. And that's what you'll hear a lot about from our panelists today. And when we talk about collaboration, it really works across multiple dimensions. Regionally, we have to look at things globally, regionally, and locally, all in parallel. From a area or expertise area, technologists need to understand policy. Policymakers need to understand technology. And through it all, there's regulatory aspects, there's economic aspects of, how do we pay to do all this? And how do we pay for that while providing reliable and affordable energy? No one group can really solve these issues unilaterally. So cooperation and collaboration are truly a key to make any of this happen. If you go to the next slide, please. All right, IEEE is hosting this session today because we are an organization of volunteer members. We're not one technical company. It is a collaboration amongst hundreds of thousands of members. It's a membership organization, the largest technical professional organization, largely made up of engineering and technology participants in industry, in academia, and in governments. And what we do is we provide platforms for engagement and consensus building on a very wide range of technology issues. But the real key is just that collaboration and sharing of information across people globally. We have representatives, members from over 190 different countries around the world. When I say we are the largest technical professional organization, we are very close now to reaching our 500,000 members across the globe, which is quite an accomplishment. And how we share that information is in a number of different ways. We have over 200 periodicals that are some general technical programs or periodicals to very detailed ones. 5 million documents, 2,000 conferences. So the key again is collaborating, information sharing for the benefit of all. And part of what you'll hear about today are the standards that drive a lot of this, because standards can certainly be an important enabler of addressing climate change, energy transformation, and just about any other technical area that you can think of. We have over 1,000 standards currently, and there's always tends to be 1,000 more in development. Some of you who are attending are from different parts of the world, maybe less familiar with IEEE standards. Many other areas, you might know ISO standards, you might know IEC standards, And certainly in every country around the world has their own standards developing organizations as well, or manages the standards within a different country. So, it can get rather complex, but, through our volunteer members, we try to, keep it, keep it open, keep it, well communicated, and really seek to help people find the technical information that they need to solve a lot of these problems. Next slide, please. So I said a little bit of this already. We use the banner of raising the world standards. And what we do, again, is we create programs and platforms where people from differing backgrounds, whether it's, if you're in industry, you might be a supplier of the technology, you might be a utility that is using the technology, and just about everything in between. And we have people involved who are very diverse. We have multiple countries involved in different standards development activities. And really, the key is consensus. None of our standards are done in a unilateral way, but really to bring people together to have very deep and intelligent conversations and build consensus. It doesn't mean 100% agreement, but deciding what we can agree upon and codifying it in a way that is going to enable these technologies to accelerate and to work in a way that they become interoperable and really key attributes to solving a lot of the world's problems. We do try to promote innovation. A lot of the standards work that we do is really on the cutting edge. It's the latest things that are in progress or sometimes very much in the future, but trying to stay ahead since technology has become faster and faster moving all the time. And of course, we want all these standards to be developed in a very sustainable and conscientious way from a societal viewpoint. Next one, please. So we often hear that we're at a crossroads, that climate change is expanding quickly upon us, and it's very important to have a lot of work going on towards achieving SDG 17 and addressing sustainable development. And as I mentioned in the opening remarks, the key is really that intersection of innovation, policy, environmental stewardship. And again, it can't be done unilaterally. And what's quite interesting in the standards world is that, perhaps decades ago, it was just really the bastion of the very, very technical people in very, very specific niche areas of technology. We have found, at least within the IEEE, in the past 5 or 10 years, we've had a tremendous influx of participation from people who are not necessarily hardcore engineers, but are looking at a lot of the technical issues from a very societal impact perspective. And that's actually helped a lot in terms of looking at how technology solves problems, not technology for technology's sake, but what are the applications, what are the solutions that they are trying to achieve. And things are moving more quickly, technologies are more dynamic, and having this great cross-representation is truly critical to having the standards that are going to enable the energy transformation that we're going up through right now. Next slide, please. All right. And finally, again, sustainable energy is really fundamental. We have a lot of technologies in the world. Everybody likes to talk about AI, quantum, cybersecurity issues, you name it. But realistically, energy is the underpinning of it all. If you don't have if you're unable to power anything, well, then everything else is for naught. And so having that power and having it be available in a sustainable manner is truly a key that we like to focus on in the standards world. Next slide, please. All right. So we're going to get into several of these areas in greater depth. We have a distinguished panel of speakers that I'm very pleased to moderate the session today. I'll just quickly mention Mark Siira is going to be our first speaker. Mark's been very involved in a wide range of standards, from smart grid to renewable energy to energy storage. He can truly cover a lot of different topics. We have Mamadou Diong. He is the chair of the IEEE 1547 standards, which really address the interconnection of renewable energy to the grid. Certainly become a more and more vital standard throughout the years, and he's got tremendous industry experience as well that he'll share with you some of the challenges and the solutions that are being undertaken. And then we'll have Maike Luiken speak. Maike is a longtime IEEE volunteer and participant across many areas. She is originally from Europe, now in Canada, and she's quite involved in our sustainability efforts. So going beyond just energy, but looking at sustainability aspects across the board, whether it be agriculture, water, waste, in a number of different areas. And she'll talk a bit about our Planet Positive initiative that is going on. So with that, I think the next slide introduces Mark. So I am going to turn the floor over to Mark Siira. And Mark, the floor is yours.
Okay, thanks, Rudi. As Rudi mentioned, I'm a volunteer with IEEE-SA, and I'm chair of a committee that focuses on distributed generation and interoperability. And the next few minutes, I'll get into what that means and how it relates to energy. Next slide. I'm going to talk about why standards are important and what the interoperability standards are focusing on. I'll also talk about a roadmap for how we plan for the future and highlight some new areas of standards that we're focusing on moving forward. And finally, a summary and a takeaway. Next slide. This is kind of a summary of why I think standards are important, and it's based on a lot of research and experience in this space. But as Rudi mentioned, standards provide a consensus view of technical requirements from a variety and broad range of technical experts. And that ability establishes a common set of terminology and frameworks that ensure clarity in the specifications and requirements. And that's particularly important in electric power as such a complex system. It's very important that standards projects are clear what the technology is and where it's being applied. Standards also lead to modularity, modular solutions. This is really what got me very excited about working on standards. Back in the early 2000s, I was working in a business that did controls for paralleling to the electric power system. And once the IEEE 1547 standard was published in 2003, we saw an 80% cost reduction in the cost of the controls in the first 2 years. So it was very dramatic and opened up a lot of new opportunities for industries, including data centers and starting to integrate renewable energy. And the last bullet really talks about an important aspect that standards form a baseline for performance, and that baseline prevents market spoilage by substandard products. And it also enables access to best-in-class technologies. Next slide. This graphic is a depiction of a spreadsheet that is one of many used for tracking where we're going in terms of standards. We track the standards, regulatory requirements, not just IEEE standards, but other standards-making organizations. And the graphic shows a spreadsheet with the projects listed along the left-hand axis, and the colored bars you see to the right show when we expect an active working group to take place or the pre-planning to take place. And we're constantly trying to get feedback from the industry and stakeholders to identify the gaps. But we're looking out 10 years, and our committee's focus is on interconnection and interoperability. Next slide. The interconnection terms, it really refers to supporting the integration of distributed energy resources and other devices. And Mamadou Diong is going to go into much more detail on that in the next presentation. Interoperability it deals with applications to an evolving smart grid model to allow devices and systems to seamlessly work together. And energy storage is an enabling technology that is starting to develop system level standards. There's been a lot of work historically on batteries, how to size, how to apply them. And now we're seeing storage as a critical system element moving forward. Next slide. This is a graphic from the National Institute of Standards and Technology, and it shows a framework that we use in developing some of the interoperability standards. It's a conceptual model of the grid electric power system, and the cloud on the top row talk about markets, operations, and service providers. The clouds in the center part of the graphic show transmission, distribution, and customer, and those are the physical delivery of electricity. And then the bottom cloud shows generation, including distributed energy resources. The terminology we use for this framework is these are domains. And as you can see, the blue lines show communications necessary to make things work, and the dotted yellow lines show electric power flows. Next slide. How we've applied that is looking at those 7 domains from 3 different perspectives. The graphic on the left summarizes those perspectives. The electric power being devices and how electricity moves and devices interconnect. The green box on the lower left talks about the networks and how the information moves from device to device. And the circle on the right shows the data requirements or information technology and what are the requirements for the data in terms of speed and a number of other attributes. And that all leads to interoperability, which is summarized in the box on the right. And that's the capability of 2 or more networks, systems, and devices to externally exchange and readily use information securely and effectively. And that continues to be a goal as we develop standards, and nearly all of them include some interoperability requirements. Next slide. And we've applied some of this directly towards the UN goals. The ESMAP established a multi-tier framework for evaluating electricity supply, and our team actually developed a standard based on these guidelines that we feel is a starting point for standardizing and enabling technology, low voltage DC. And that's, I think we're going to see a lot of activity in that area moving forward. Next slide talks about the specific standard we developed. Its title is P2030.10.1. It's a standard for electricity access for Tier 2 and Tier 3 ESMAP applications, and that's residential sites that have 4 hours to 8 hours of electricity available, and the size range are typically 550 watts to 800 watts. So they're small DC systems, and we published this standard last year in 2023, and our hope is that more DC standards development will continue. Another related important standard that was published, it's actually in 2022, was a guide for energy storage interconnection that dealt with the bidirectional power flow of electricity from a battery and to a battery. And that's also enabled grid forming inverter applications and a grid bridging system. We've seen some applications in Alaska where an energy storage device and an inverter with either a wind source or solar source has been used to supplement and basically replace the diesel generators used in the villages, allowing the diesel generators to be used only when they're needed at peak, and about 60% reduction in diesel fuel consumption based on this grid bridging application. So we're very excited that this has a lot of economic benefits, as well as providing low-cost, reliable power to these remote sites. Next slide. As we look forward, we're continuing to evaluate opportunities for standards for grid forming inverters, and those are inverters that can form an electrical island. Those aren't typically used in grid-connected sites today, and the focus of applying that is in the transmission connection systems over 100,000 volts, and I listed 2 standards that are being developed in that area. There's also more focus on application-specific gaps, such as providing 50 hertz guidelines as part of our standards, and not just 60 hertz. The DC systems, as I mentioned earlier on the previous slides, some more focus on remote systems and providing support via standards or guidelines. And one thing I wanted to point out that we're seeing strongly is that there is more reliance on power systems models to assist in verification of large systems. This allows us to simulate the effect on the power system rather than doing large-scale testing. And that's hopefully going to reduce the speed to market and improve the availability and reliability of these systems. And we are also continually trying to outreach through providing training, presentations through webinars like this, and outreach to the industry. The next slide. One method of that is a conformity assessment program, which is a certification process that's in place for interconnections, where we would credential and train individuals that would be able to verify that these installations in the field are compliant with this standard. Let's go. New slide. This is my last slide. Just wanted to highlight the summary points is that the electric power systems is complex and it's constantly evolving. We've got new power electronics applications, more complex interfaces, and cybersecurity is being dealt with at all levels of the standards development. And, you know, many changes are continuing to update and you know, identify new areas. We believe that standards can help the UN progress towards the Sustainable Development Goals. And I highlighted the different goals and the icons that are available to support them. But the ones I've talked about today are Guideline 7, and Rudi and Karen talked about the Guideline 17. And I think all these other ones also apply. Lastly, we're going to see technology changes related to grid forming inverters and its application to high voltage and remote villages. 50 hertz technical requirements, more international and global application of the standards. And then we're starting to see applications such as long duration energy storage. So that completes my presentation, and I think the next slide will introduce Mamadou Diong to talk more about the interconnection standards and how the industry's evolved. Mamadou?
Thank you, Mark. Good afternoon, everyone. Again, thank you very much for joining this presentation. Thanks again to Mark and previous speakers for introducing us, especially Rudi. Again, my name is Mamadou Diong. I'm actually a supervisor at Dominion Energy, which is the largest energy provider here in the state of Virginia. I have about 17 years of experience in the energy industry, but 15 years of which I was part of the Dominion Energy team. I'm also the chair of the 1547 standard, which I will be going over a little bit to discuss what role it plays currently in the energy landscape. Before I get started, I just wanted to just give you a little story. Growing up, I've always been fascinated by anything related to energy, which really led me to being interested in the field of electrical engineering. Why? Because I learned growing up from a young age that not everyone has access to energy, has a sustainable energy sources and reliable energy, especially in countries outside third world countries. But also countries where people may have abundance of sun and wind and other renewable, but they are not really able to have reliable energy like here in the U.S. We can really say that we are really having profiting of it. Now, with that being said, I learned through my through those years of experience that next slide that power typically runs in a specific way, meaning that it always goes from the source to actually the customers, going through some different level of transformation, going from a high voltage to the low voltage, which is typically what we see at the consumer level, at the household level. And next slide. But to dive a little deeper, if you look at how this electric power system evolved, early in the years, just like I mentioned, we actually really knew that there were benefit of having reliable electricity, reliable supply, and the system were isolated in specific ways. But what people started getting into is that as the population grows, as people's need of power grows, we really started to get into building a stronger, more reliable power system that currently, as we see, is more AC-based power system with local systems that are growing as the demand is growing. But what people didn't always see is that building reliable system requires an emphasis on standards so that deal with safety and interoperability, but also infrastructure, how those are able to maintain the reliability of the power system. So, and not only that, technology keep advancing, and everyone knows that technology of today's of 10 years ago is not the same technology that we've seen or we're seeing nowadays. And different countries, different regions have dealt with those in different ways. With the advance of technology and the increasing demand of energy. And that's why we're mentioning here in this slide deregulation and how people have tried to create other opportunities to increase the amount of diversity in the power system, in the electric power system. Next slide. Now, over the years now, we started getting an emergence of more generation that are taking part of the support of those but are trying to support the reliability and the safety of the power system, of the electric grid. So those can be in different kind. It could be what we call synchronous generator, rotating machines, or it could be in the form of renewable generation, which we typically call as distributed energy resources, solar, wind, battery, you name it. So those generation really coming into the picture created a lot more challenges and also some need to add more regulation, more standardization. Hence, you see again some standard interconnection that came, for instance, in the case of the United States in 2005, and the advent of the 1547 standard, which I will be discussing a little later. But again, all of that, those technology had to learn or had to be interoperable with the existing power grid, which really the technology hasn't really changed over the years. It's still power flowing from the power source to the customer with some transformation in between. It's still the same principle. It hasn't changed, but there's some other challenges that needed to be worked on. Go to the next slide, please. With that being said, just to kind of give you a quick summary of how everything has evolved. We used to have a kind of mesh network kind of shaped network on the power grid, which nowadays have changed to a power system where power doesn't always flow from one way, meaning from the source to the grid, from the stronger source, which is our power grid, to the customers. Now we're seeing more generation pushing power the other direction. So the bidirectionality is something that many people have to, I would say almost all grids that I know of have to deal with. Those bring new challenges to the grids, even to modernizing grids as we see it, because that increasing amount and penetration of renewable requires different thinking. How do you really make sure that it doesn't actually reduce or impact the quality of your energy sources and the reliability of your sources? And some of those drivers, again, you can see here for looking at how to tackle those challenges can be, again, the increased number of smart meters and smart generation and distributed energy generation. Next slide, please. With that being said, IEEE, and just like Mark mentioned, has recognized, and some other entities, IEC and other standard, that the need for standardization to help in that transition to that new modern power grid. One of the things that IEEE has done to kind of support those challenges, those changes to those evolution of the grid is, one typical example is the 1547 standard, which is the standard for interconnection and interoperability of the distributed energy resources. So initially, back in 2005, around the time of the Federal Energy Act here in the US, it was solely focused on small generation, how it should be interacting with the existing power grid. But as things evolve, as penetration of those generation, wind, the solar, which we call photovoltaic, increase, there was a recognition that things need to be changed and the standard need to be evolved. That's what led to writing a new standard, the 1547/2018, which now look at a little bit more specificity, more complexities, and how to deal with additional technology, new generation technology, without being really biased towards some technology or others, and all for the sake of ensuring the safety, the reliability, and interoperability of the power system. So this is how one way of 1547 and IEEE standard has tried to support that transition from the previous star-based system to now a little bit more modern bidirectional grid. Next slide. And again, other drivers, just to continue on that adaptation, because that's the key, just being able to adapt the standard to the new reality, being able to support that transition to a more modern grid. Again, some of those drivers can be of many sorts. For instance, how, for instance, you're able to understand the need of the technology. Some people talk, for instance, about how do you keep your system a little stronger, such that in the case of natural disasters or things like that, your system is able to handle those and be able to, how would I say, ride through some of those events and provide that necessary service, that energy services to everyone. So technologies came along those years, such as grid forming inverters, and also other challenges came through, such as cybersecurity, because a lot of those technology are interconnected. There are technology that are much smarter, that are utilize technology that are prone to bad actors who want to disturb the safety and reliability. So all of those tech challenges had to be addressed in some ways. And if you see in the next slide, you will see that 1547 recognize some of those challenges, and for the sake of supporting the transition to industry leaders and how they could tackle some of those challenges, IEEE was able to, and through collaboration, just like Mark mentioned, a lot of collaboration again plays into how we do those standards. Collaboration within expert, industry, academia, and manufacturer to figure out what's the best way to ensure that we have all the tools that we need and the understanding and the training and the education for us to be able to keep maintaining the safety and the reliability and the automobility. So some example are, for instance, 1547.3 here, for instance, that was put together, a guide to support cybersecurity when dealing with distributed energy resources in the power system. How about islanding? And just not long ago, I was approached by some colleagues in West Africa and Central Africa and Southern Africa asking us, okay, we're seeing a lot more of those generations coming to our system. And then those generations tend to want to stay away from the power grid. Sometimes we really want them to stay disconnected from the power grid, but how do you deal with those? How do you make sure that when they come back to us, they don't actually hurt us instead of helping us? So that's where 1547.4 is trying to support some of those challenges, those engineers and operators and regulators in figuring out what's the best way to handle some of those challenges coming to our power system. Again, those are just few examples of how standards are trying to support the adoption and the evolution of those power grids. Next slide. Now, beyond, just like I mentioned earlier, beyond setting up standard, IEEE also try to support and collaborate and share knowledge with the industry stakeholders by attending a lot of meetings. In my case, for instance, I regularly, each year, I travel out in Africa through the IEEE Power Africa Experience Conference to discuss with energy leaders, regulators, and share with them our experience with standard and our know-how, because they're also in the verge of getting to the level where we are now in the US, for instance, where we're getting increasingly high penetration of those renewable energy and other generation that could make it a little bit more complex to manage and operate the power system and keep it safe and reliable. So through collaboration and support, we helping them get to where they need, and then also supporting some of their specific use cases, such as the one I mentioned earlier about the microgrid. That was a colleague from South Africa that actually came to me and asked me about some of those challenges they have. Again, this just one example of how knowledge sharing and collaboration is key. We're also learning from them because they have a different need that the standards need to adapt to the need of the community and other stakeholders. So those are learning also we gain from reaching out to those colleagues. The other outreach that I'm showing here on the right-hand side to academia, especially in other energy sectors. Back in 2019, we were able to travel to Ghana to demonstrate how we can commission a large-scale solar system, a photovoltaic system, where we were able to show the best practices, our know-how on how to do it. Again, this is all for the sake of supporting and doing knowledge sharing toward stakeholders, other emerging countries, such as and anyone, and especially academia, on what's the most important in toward a successful and sustainable power system. With that, I will hand the rein now to Maike for her to discuss the energy sustainability going forward. Thank you. Thank you all.
Thank you very much, Mamadou. Much appreciated. So my name is Maike Luiken. I'm joining you today from Canada, and I have the honor and privilege to share the IEEE Planet Positive 2030 initiative. That is actually an initiative of the IEEE Standards Association. Next slide, please. So I like to set our context a little bit at a global level, not in the detailed technical level. So ultimately, the goal that we are trying to achieve is, as I like to put it, a long-term healthy planetary biosphere. 50 years from now, 100 years from now, 1,000 years from now, 10,000 years from now. And I've been trying to put together on one slide what that actually means in terms of challenge and context. So the United Nations was very forward-looking by putting together the Sustainable Development Goals. So one of the challenges is to actually achieve the 17 goals. The second one, which is pulling out essentially SDG 13, is to address what is happening in terms of climate change, accelerating climate change, and the damage that has already been caused by global warming and will continue to be caused until we have essentially healed the system. So the most urgent steps that we need to take under this item number 2 is to prevent as much as possible further elevation of the greenhouse gas levels in the atmosphere. So we call that mitigation. And as I said, at the same time, we need to adapt to the current impacts and those to come from global warming, like severe weather, ocean level rising, Arctic ice diminishing, and so on. But we cannot stop there. We also need to, once we have succeeded in the prevention of further rising of GHG levels in the atmosphere, we actually need to reduce the greenhouse gas levels in the atmosphere to get closer to pre-industrial levels. In other words, what our industrialization caused in terms of unbalancing or imbalance of the atmosphere, we need to reverse. Through our footprint as humanity in the last couple of hundred years, mainly maybe, we also have done quite a bit of destruction of Earth's ecosystems. We do need to regenerate those. So that is my third point. And we need to regenerate the Earth's ecosystems for the long term. And a fourth item is to achieve essentially resources availability in the long term. And that is expressed well through the concept of a circular economy or a no waste economy. So we have to behave more like nature, but having no waste. So that's 4 points in setting our context. Next slide, please. And we have already talked about Ban Ki-moon's statement, my favorite, that energy is the golden thread that connects economic growth, increased social equity, and a healthy environment, and that we will not be able to achieve sustainable development without sustainable energy. And that brings us to the global energy systems transformation. Next slide. So to put the size of the challenge in front of us, I pulled this slide from Our World in Data about the global primary energy consumption by source from 2020. So we have oil, coal, gas, nuclear, hydropower, wind, etc. So on the far right, they're about just under 16% of energy sources or energy pulled from energy sources that are low carbon sources. That means that if we continue with the same level of energy consumption, that we need about 5-6 times more energy from low carbon sources in the long run. And as fast as possible, because oil, coal, gas generates a lot of greenhouse gas emissions, not just CO2, but also methane and other pollutants. So that is the size of our challenge, not to mention that presumably we may want to use more energy data centers are one example, but we also have 800 million people who are actually not yet connected to electricity and live with very basic energy sources or energy supply. So as humans change their lifestyle, they may actually also need more energy. So this is the challenge in front of us. Next slide, please. So with the initiative, the Planet Positive 2030 initiative, we wanted to take a step back and look at, okay, where do we want to be in 2030, back us to today, and set goals and essentially take an approach of what is needed for different ecosystems in order to achieve this Planet Positive 2030. So what does it mean? First of all, it's a global community of, and it's the numbers vary as we go through time. We started this about 2 years ago. Around 300, 400 people working together. And this is a global initiative. The people working on this topic are coming from all kinds of professions and all kinds of backgrounds. I will have a couple of things to say about that a little bit later. But why do we call it Planet Positive? It's essentially referring to the fact that we have to give back more than we take from the planet, hence Planet Positive. And why 2030? Well, focusing on the goal of getting to net zero GHG, greenhouse gas emissions, by 2050, pushes the date too far out for action. So we picked the 2030, like have been by many other organizations, because it also lines up with the goal of reducing greenhouse gas emissions to 50% of the 2005 output globally. So that is the essentially the history or the description of Planet Positive in its raison d'être. So we set two what we call impossible goals. One is transform society and infrastructure to achieve planet positivity. And the second one is aimed at the technology solutions that either need to be implemented much faster and much more widely, or actually also identify gaps and develop roadmaps to address those gaps. We divided this into two projects. One is a compendium called Strong Sustainability by Design. You see an image on the right-hand side here and a QR code to the document in draft form that was published last year in June. And we're looking forward in the next few months to come up with version 1 after incorporating feedback from the public. The second goal is to essentially come up with a framework, accountable sustainability by design, because if we do not measure the impact of our actions, then we cannot make good decisions. We like a good framework with good metrics, good key performance indicators, so we can have solid evidence-based decisions. Next slide, please. So in this compendium, where we had about just under 100 authors from just under 30 countries, and there may have been more, not everybody indicated the country of origin. We have one layout where we identify issues and recommendations for the various topics. So one topic was to lay out guiding principles. And here's a paraphrasing of 3 of the 10, 11 guiding principles. And in the addendum to the slides, you'll have the complete set of these 3. And in the document under the QR code, you can find all the information. So one of the guiding principles is that we need the energy systems transformation. And when we talk about energy systems transformation, then we talk about energy systems of all kinds, not just the power system, but the transformation of the power system will help other sectors essentially transform as sustainable energy becomes available through the power system. The second part is the regenerative imperative and a circular economy, so that the planning and implementation has to go beyond our current models and has to take into account the resource retention and no waste paradigms in order to achieve sustainability for the Earth's biosphere and, of course, for people. And the third one listed here is climate change mitigation and adaptation, that we have to address those items. And with that, we can go to the next slide. So a few of the recommendations. And in this particular case, I'm talking virtually only to the energy-related recommendations. There are many more in the document, but this is a topic for today. So if we want to achieve energy systems transformation, we should not only look at how we get different energy sources that are low carbon, we also need to look at how we are using energy. So the first realization should be that we should achieve energy efficiencies across all types of energy consumption as an early target. That is essentially the low-hanging fruit. So number one, generate efficiencies or realize energy efficiencies. The second one would be to look at energy conservation as opposed to energy efficiencies. Because if we don't need to use energy, then we don't need to produce it and we don't need to pay for it. So this is an educational campaign potentially. We can incentivize energy conservation, and we can give control over energy consumption to the user. So London Hydro has what's called the Green Button program, and it gives much information to a consumer, but who could be a residence or a business or industry, to decide when to use energy and what the impact of changing behaviors might be. Next slide, please. So from energy efficiencies and energy conservation, we move now to the transition from fossil fuel-based energy to low or no emission, clean, resilient, primary electricity-based energy systems as a priority. And it has to be implemented in a contextualized, sustainable way. The availability of low carbon energy sources varies greatly by geographic location. Kenya, for example, has fantastic geothermal sources. Other places have great opportunity for wind or for solar. Other locations may have very little opportunity if we look at the high Arctic, for example. And so maybe there we need small modular reactors. So it has to be contextualized, not just to the availability of energy sources, but of course to the user, what is required. It was already mentioned that technology is changing very quickly, very often. And in the last 10 years, it's unbelievable what has changed. So we should keep our eyes open to new ways of harvesting energy from low emission sources, such as the ocean. It's not just wind turbines in the ocean that could help. Run of the river is another way of sourcing low carbon energy. And of course, we need to support the exploration and development of new ways of energy storage and transport. Next slide, please. It was already mentioned by Rudi at the introduction that one of the key items to enable the energy transition is collaboration and cooperation between the different rights holders and stakeholders. So it's hugely important that we bring together government, finance, local stakeholders, different countries, and of course the technologists to make suggestions about solutions, to work together in a global fashion, because we cannot leave any country behind. We cannot leave people behind. So collaboration and cooperation is essential to move forward. And it's also a huge enabler to erase some of the inequities that we're seeing around the globe today. So this whole transition is actually a huge opportunity for us to deal with some of these inequities. Next slide, please. Under the UN Climate Action 5 Ways in 2022, there were some very interesting recommendations that we have been repeating in the Planet Positive 2030 compendium. And one of them is to make renewable energy technology a global public good. It's to improve global access to components and raw materials, to level the playing fields for renewable energy technologies versus fossil fuel-based energy, shift subsidies from fossil fuels to renewable energy, and triple investment for renewables. So this is a good roadmap to essentially incentivize the energy transformation, energy systems transformation. We also like to encourage and support government, industry, and business commitments to the outcome of the COP28 declaration. Next slide, please. And that includes support for nuclear development. It was already mentioned that we need power systems that are reliable. Maybe we should also call it resilient, so that we have power systems that can withstand severe weather events, for example. So we need resilient energy availability for infrastructure that's critical to society and our economy. So the community power systems need to be resilient to extreme weather events. In going forward, we also need to look at how we can incorporate the different risk scenarios in the design of power systems. Risk scenarios from heat waves to cooling water potentially drying up, energy demand changing with, for example, e-vehicles and so on. And those risks are going to be different in different locations. For example, I had the opportunity to listen to quite a few presenters about the Alaskan power system just a week ago. And one of the things that was pointed out is that e-vehicles have a bit of a problem in the high north, because the batteries cannot withstand the low temperatures. So maybe an e-vehicle is not the right answer. Maybe it should be a hydrogen-powered vehicle, or whatever other sources or whatever other solutions we might come up with. So being in the context and planning for context is essential. Another item that was recommended is improve the efficiency of cooling equipment. We saw the ruling in Switzerland that made the government responsible for taking action to essentially help the citizens deal with the impact of climate change. And that was a item related to cooling. That's just maybe a month ago. So, of course, that doesn't only relate to cooling. We also need to change the heating systems from fossil fuel-based to electrical or whatever else we might come up with. Next slide, please. So this was a sampling of recommendations. I'm going to talk about the last two in a minute. There are many, many more. There will be some in the addendum. And there is a long, long list with each chapter, with each issue in the document. So if you're interested, please have a look. It's freely available on the web at the QR code that I provided earlier. So what does this all mean in terms of standards and standards development? It was already mentioned that standards lead to like making things work, of course, making equipment interoperable. It can lead to regulations development. And ultimately, what we need is that the standards also address sustainability concerns, say resources or emissions, and they have then the chance to lead to development of regulations that could spawn interoperability of regulations between jurisdictions. Particular for power systems, we really want to see interoperability of the regulations between countries so we can interconnect easily and so on. The second item is to essentially say that we'll design the new energy systems infrastructure such that the systems are sustainable by design, not just functioning and delivering the power, but also looking at the components that are used in the infrastructure and have them designed in such a fashion that at the end of use, the material used in these components can be reused to build new components. So that would be essentially the circular economy or no waste principle. And if we can, we should incorporate regenerative design principles if at all possible. So where do we go from here? We are forming different groups. One is working on will be working on green hydrogen. One is working on marine carbon dioxide removal. In other words, we will never be entirely net zero without having either CO2 or methane removal as part of the solution to get truly to net zero. We are looking at, another group is looking at energy systems transformation in the Arctic, and so on. So electrification of ports is another topic that's being addressed. So we have different ways out of the standards, IEEE Standards Association and other units in the IEEE to form groups that will take the recommendations or issues that are identified further and essentially return potentially white papers or roadmaps or standards that will hopefully help with solutions in the long run. And with that, I thank you very much.
All right, thank you very much, Maike, and thank you to all our panelists. We are going to do a bit of Q&A, so anyone who has questions in the audience, feel free to put that in the chat. We'll be able to see that, and if they're directed at a specific panelist, you can do that as well. Let us know. I will get us started with a couple of questions while people think of things they might want to ask. And Maike, I'll start with you, since you were just talking through a lot of different energy transformation issues. Certainly there's a multitude of different issues to be addressed, but are there any particular challenges that you consider to be the greatest amongst those challenges to addressing energy transformation? Things that might be a little bit more cross-cutting across some of the topics that you discussed.
Well, I think we cannot overemphasize the need of international collaboration, international partnerships between the various stakeholders, and not just actually at the international level, but when it comes to implementation at the local level. We are not going to succeed without the buy-in of all parties concerned. So this piece of being able to bring together the various stakeholders and rights holders and interested parties is essential. The other thing that I'd like to point out is that information is like good technical information is flowing too slowly. I've had the opportunity to talk to many people around the globe, and one of them was in Australia, where in Central Australia, on a large farm, and I noticed that they use diesel and a little bit of wind power, very little, to power essentially their operation. And this was in 2017, which was a year when the first report came out that sub-Saharan Africa would be much better off using large solar generation than anything else. It was more financially rewarding. And so I asked the question to the owners of this farm in Australia, why not solar? And they said, well, we had done an assessment and it was too expensive, not feasible. And my only question to follow up was, and when was this done? 7 years earlier. The price of solar had plummeted in that time frame. So we need to get information out to people who are making decisions very quickly so that they can actually make good evidence-based decisions. So that's one of the other challenges that I see.
All right.
I mean, you can take it to another piece and say, we also need to express technical knowledge such that the people who are making decisions understand it. We cannot keep technical knowledge in academic language.
All right. Thank you, Maike. I'm actually going to pivot off of that question and follow up with Mamadou on this one. We had talked about how Maike's made the point of looking at different parts of the world and how the challenges can be different in different regions, different climates. Some of the standards that get developed, whether they're IEEE standards or standards from other organizations, sometimes they can be a little bit centric to the region that they were developed within. I know one of the examples I hear very frequently is on some of the interconnection standards. Perhaps they were built for 60 hertz systems versus 50 hertz. Could you say a bit about the application of many of the standards and how they can be implemented around the world and the challenges, what works, what doesn't?
Thank you, Rudi. Yeah, that's a great question. In my travels with IEEE Power and Energy Society, I did also hear the same challenges from countries like India or Western and actually most of Africa, where they're all a 50 hertz system, but our standard is really focused on a 60 hertz system, which the United States is really among the only ones that have a 60 hertz system. Maybe Canada, you can add Canada to that, and in my case, backyard. But one thing that people realize is that the fact that it's really been written to really respond to needs of higher penetration that we see in the US, they have that feeling or that thought that this may not be really applicable to what they do, but it's not really true. a lot of the things in the standard that we have, like 1547, are always applicable to also the 50-year system. But the difficulty a lot of time is when you look at the 50-year system and the rating for voltage and frequency or things like that, it may not be exactly the same thing, same rate, the same threshold, or that people should be looking at. So translating that into the reality of that specific country, like in India, can be a challenge. But studies have shown that actually the same need that a lot of countries have in terms of how interoperable some of those new generation like solar, wind, bring to the front are similar to those need outside of the country in US, outside of the US. It's just a matter of figuring out how to apply it. So we are collaborating with them, working with them, doing studies to figure out what's the best way to apply it. But also educating the regulators to get them to understand that, yes, when you connect two different sources, one is pushing power straight to the customer, the other one is leaving from the customer to the transmission, there need to be some kind of coordination between. There need to be some communication between those two, or just like Maike mentioned, to be able to maintain the sustainability, there need to be that communicate, that interoperability, I would say integration. And if you don't have it, then one will do one thing, thinking that that's what the system needs, when actually that's not what's needed. So all of those things, it's still the same reality, the same kind of challenges that they have. It's just they haven't reached that level of or that point where they need that because of the different level of penetration. But it's coming. That's some of the things that we've been sharing with them to show them. Eventually, you will get to that level. It's good to start thinking about it now, and we can help adapt some of those to the realities as needed.
All right, thank you for that, Mo. And you know, and certainly, yes, I mean, some of the technical parameters, you know, need to be understood on a local basis. And kind of speaking of a local basis, I want to throw it over to you, Mark. You know, so it's not always just necessarily the technical parameters, but sort of the scale, the locale that you're dealing with, and the challenges. So many of the things we look at in the standards world, or many of the topics that we talk about at IEEE, very often focus on, you know, the large utilities, the bulk power system. But then there's also the challenge of remote villages and you know, sort of the areas that are not connected to large scale systems. Could you speak a little bit about some of the examples that we could be addressing on energy transformation when it comes to, say, a remote village?
Yeah, thanks, Rudi. It's an area we've been aware of, and the technology is kind of catching up with our capability to deploy it. The example in a remote village I touched on was that historically they use diesel generators for their electric power system, and that's a costly endeavor to get fuel in some of these remote sites. And the technology of grid forming inverters and a cost-effective energy storage battery, maybe combined with a wind turbine or a solar panel, seems to be able to be a much more cost-effective solution, and ability to provide reliable power that's available more time than would be if we just deployed the diesel generators. So I think that is one area. And the other standard I touched on was the UN, the goal number 7, where we were trying to define DC power systems and execute a safety standard for very small residential applications. And that allows the manufacturers to have a minimum level of quality in providing the safe application of a small solar battery storage system for a residential application. Originally, these projects were going to be broader and in terms of larger scale and then we may have to revisit that. The COVID pandemic disrupted some of those projects. And now I think we can look, as we move forward, we can focus more on remote applications. Thanks.
All right, thank you, Mark. We did have a couple of other questions that have come in through the chat, and I'll start at a high level. There was first a question about, have there been standards developed relating to artificial intelligence? And I can start the discussion on that, and certainly the answer is yes. I think it's a similar question to saying, have there been standards for the power system? There's so many different underlying aspects of it. I know within our area, a lot of the early artificial intelligence standards that were starting to come out had to do more with ethical applications, more societal impact. That was like one set that was going on with active standards working groups. Then there have been other sets of standards working groups that are looking more at some of the computational issues, like the computer science things to think about. Say like efficient computing. AI is certainly a very energy intensive, and so that becomes a bit of a challenge because you want it can actually solve problems for you, but then it's also creating new energy problems for you. So I think I'll just go quickly to Mamadou. We were actually talking earlier this week. I know in your region, you're very challenged with the demand side. While AI can solve a lot of problems and people think it's very cool and interesting, it creates a lot of challenges for you for when you're in your utility role. Do you want to speak to that?
Yes, that's correct. So it is a lot of challenges to us. As I mentioned at the beginning when I was starting my presentation, we are the largest electric utility in the state of Virginia here in the U.S. But the other thing that I didn't mention is that we are home to the largest data center concentration in the world. So 70% of all internet traffic go through our service territory. So that's one of the challenge number one we have is being able to provide power for those equipment, energy hungry equipment. They're always running 24/7. And then they always want power, and they want that power to be reliable, sustainable, but also resilient. It's like Maike mentioned, resiliency. But the challenge now we're getting more is now we're getting AI coming. AI is not as predictable as those data centers, the traditional one. Why they're not predictable? When the system under those computers are trying to train the AI model for it to be able to do something and know how to compute some specific computation, it is really using a lot of power. But then when it's done training, it's dormant. It's not doing anything. So for us, the utility, it's a challenge for us to figure out, do I put more energy, more investment in this area? Do I push more power on that specific location? What if it's not needed at the time? Then you create other problem, other situation, other operational and planning related issues that's just making it a little bit more complex than it need to be. So that's still an ongoing discussion we're having with those industries to figure out what's the best way to do it. But I can tell you that it's not a simple discussion. It's not simple at all. It's bringing in a whole other set of challenges.
Yeah, thanks for that. And it actually makes me think that Maike, with your Planet Positive work that's going on, I know I've heard some discussions about water usage, and the sustainable use of water when it comes to AI and data centers. I would imagine there's other things that people are looking at and perhaps some other standards areas that there's perhaps a need in the future. Did you want to comment on that as well?
Who did you want to comment, me or
you? Yes, from the work that's going on that you were talking about in Planet Positive.
so
I didn't know to what level these issues were being addressed.
So water is, of course, an issue with the energy system in generation. And so when you talk about data centers and AI, there's water use depending on what the cooling system is, where the data center is located, and also related to what energy source is being used. So if the data center is in Quebec, then there's water use associated with low carbon energy because it comes from hydro dams. If it's done in Ontario, then 56% is from a nuclear source, so they use water for cooling. So when you talk about data centers, there's water use in multiple dimensions. And so the placement has to be done very carefully so that you don't end up in a water scarce area. The same would apply to, say, green hydrogen production. If you use electrolyzers, for each kilogram of hydrogen, you need, at a minimum, 9 liters of water. And depending on what the quality of water is that's available, it could be 20 liters. So water and energy and water and cooling are really central items that needs to be addressed for every planning exercise and for every placement. So the water energy nexus is, it's here to stay.
Yeah, great, thanks. And I see Mark wanted to comment on that, and I'll ask you a follow-up question to that as well, Mark, to whatever your comment was. I was going to add that as we, when we talk AI, we talk a lot about the digitalization of the world in a sense, and we see a lot more digitalization going on within energy, which sort of leads to more vulnerabilities from a cybersecurity standpoint. So I'll let you comment on what you were going to say, but then I'll ask you if you want to comment on some of the cybersecurity, since I know some of the work you've done is addressing that area as well.
Okay. Yeah, thanks. Just to follow what Maike said on the energy and water, we're working on some industry connections activities, and I've been finding as I network with people in the space that the Department of Energy and the Department of Commerce are working to develop tools to help you analyze water consumption as well as energy consumption. We're fortunate we've got good access to a lot of data, even local data regarding energy, and we're very, in the near future, going to have tools available to analyze both energy and water, and that's really going to develop some significant high leverage solutions that benefit both. Regarding the cybersecurity question, it seems like it's coming up everywhere. Almost all of our standards have an aspect of it. It's being applied to most communications related standards. And as I mentioned earlier, the interoperability requirements that are being put in most of the technical standards include cybersecurity metrics, and that's continuing to evolve, but it's being dealt with at multiple layers of the power system. So it's a very complex issue, but it's being dealt with very seriously at all levels. Thanks. Hope that answered your question.
Yes, great. Thank you, Mark. I see we have just a few minutes left, so I think maybe what we could do is conclude with a word from each of you, no more than 1 minute, on where do you think the next challenges lie, particularly on the intersection of technology and policy, because it's seems to be becoming more intertwined as time goes on, with goals that are set by regulatory authorities with the technical realities that may be there, particularly in the energy industry but the technology industry at large. So I'll go to Mamadou first.
Thank you, Rudi. For me, the biggest challenge that I see is being able to keep up with the evolution of the technology and the energy landscape. Mark mentioned, for instance, in one of his slides, that typically a standard takes 10 years to go from drafting to publication. What we see now, the reality is that this is too long. We cannot do 10 years to write a standard. It has to be a little quicker than that, because technology doesn't wait for us, and the regulator really needs something now, and also engineers, for them to be able to adapt the system and the practices to the new reality. So what we're looking at changing at it to something shorter, maybe every 3 years, having a standard updated right away when you finish, continue again revising the standard. But it's going to be a challenge because it requires time, resource, and availability of those people with the knowledge, those SME subject matter experts, for them to be involved and help support that. So that's what I think in my mind is the biggest challenge coming for us.
Thanks. Mark?
Yeah, the one that comes to mind is I mentioned a project that we developed for the UN Sustainability Goal 7 based on the ESMAP tiers. And I would like to see a way to have more collaborative working groups with representatives from the different time zones and collaboratively move it forward. You know, one of the practical issues is many of the contributors in that standard were based in India and Asia, and it's a 12-hour time difference from North America. But we're always looking for ways to get this collaboration moving and keep it moving. And so that's an opportunity for us moving forward. Thanks.
All right, thanks, Mark. And Maike, final word from you.
Well, thank you very much. And I'm going to pick up on Mark talking about opportunities rather than challenges. So I think this energy systems transformation is also a huge opportunity for us. And we need to overcome some of the negative attitudes. And I think one way to do that is to look at the opportunity for co-benefits. So we already mentioned the Arctic and the diesel project that Mark brought forward. Well, one of the big, huge co-benefits is that the diesel generator is not running all the time, and people do not have to suffer through the noise. We heard that from multiple communities. The diesel generators, they generate noise, it smells, and the barrels are essentially contaminating the environment, the empty diesel containers. Another opportunity for co-benefit is health in general. There was a study done for the metropolitan area of Toronto to look at what the health benefits would be if transportation was emission-free. So whether it's electric vehicles or hydrogen vehicles doesn't really matter, but we wouldn't have the pollution from gas-powered and diesel-powered vehicles. And the outcome was that by the time half the vehicles would be changed from gas powered or like fossil fuel powered to clean energy powered, the next vehicle would save the health units around $8,000–9,000 Canadian, simply by through health benefits for the community. We're not even talking about noise pollution. We're not even talking about less erosion because there's less NOxes and SOxes in the atmosphere. So I think if we come across challenges by different stakeholders who challenge us on whether this energy systems transformation is beneficial, we need to look at the system. We have to take a systems approach and take the opportunity to point out all the other benefits that we are realizing by changing the energy system from fossil fuel-based to clean, sustainable, resilient, and so on. Thank you very much.
All right. Thank you very much, Maike. And thank you very much to all our panelists today, as well as thank you to our audience members who took their time to listen in. We greatly appreciate it. With that, I'm going to give the final word to Karen Mulberry to wrap us up. So the floor is yours, Karen.
Thank you, Rudi. I just want to thank everyone for participating in our session. We do appreciate you being here. You also have the opportunity to listen to the recording because it will be posted on the STI Forum website. So you can go back to the recording of this session. And we will also post our presentations, along with the addendum, which has some compendium slides that you might be interested in as you look further into sustainable energy and what we're doing, what we need to do, and how you might help address the challenges that we are facing to make this a reality. Thank you very much for attending our session. We appreciate you being here with us.